All right, welcome back. So we're going to solve an example here that, spoiler alert, is not exact. Okay, but even if it's not exact, we can still do something with it. Okay, so let's go ahead. Let's do this. Let's see what we can do with this. So first, we're going to check. We're going to pretend that we don't know that it's not exact because how would you know unless I told you? So p of xy is 5x squared y plus 6x cubed y squared plus 4x y squared. And we're going to check partial of p with respect to y. So partial of p with respect to y is 5x squared. Let me rewrite that. 5. This is now the third time I'm starting on this problem, so I'm not going to start over just because of that. Plus 12x cubed y plus, sorry, 8xy. Okay, we're going to compare that, of course, with the partial of q with respect to x, where our q of xy is, of course, 2x cubed plus 3x to the fourth y plus 3x squared y. Okay, so partial of q with respect to x is going to be 6x squared plus 12x cubed y. Well, that looks good, but that 6x squared doesn't. Plus 6xy. Okay, so they are not the same, are they? No, they are not the same. Okay. What should we do? Okay, so what we're going to do is we're going to multiply. We're going to hope that we can multiply this whole equation by a factor to make it exact. Okay. So that is our hope. So we're going to start, in this example, we're going to try some x to the n times y to the m. So we're going to try a factor of x to the n, y to the m. And see what happens. Okay, so if we do that, we're going to go ahead and take our new equation, plenty of space. Okay, so there was our old equation. We're going to have to make some, play around with it a little bit. So I'm going to have an x to the n, y to the m here. And then also an x to the n, y to the m on the other term. Okay, so now when I do that, what am I going to get on the next line? Let me just do the multiplication out first. So 5x to the n plus 2, y to the m plus 1, plus 6x to the n plus 3, y to the m plus 2, plus 4x to the n plus 1, y to the m plus 2, plus 2x to the n plus 3, y to the m, plus 3x to the n plus 4, y to the m, plus, yeah, I can do it in there, plus 3x to the n plus 2 y to the m plus 1. Oh, I forgot something. There and there. That should have gotten a dx. Sorry about that. Plus, let's move this part down. That should have gotten a dy equaling 0. Okay. All right, let me just double check because I did do a couple of things. So let's see, 5x n plus 2, y to the m plus 1, 6x n plus 3, y to the m plus 2, 4x n plus 1, y to the m plus 2 with a dx, 2x to the n plus 3, y to the m, good, 4x or 3x to the n plus 4, y to the m plus 1. Okay, good thing I double checked. I'm a little disappointed in you guys for not telling me I made that mistake, but that's okay. I forgive you because you're not really here. Okay, you're not really here till later. 3x to the n plus 2, y to the m plus 1, dy equals 0. Okay. Now, let's go ahead and check. Now we're going to take our derivatives and we're going to set them equal to each other so that we can determine what are the values of n and m that will make this an exact equation. Okay, so partial of p with respect to x, and let me call it p tilde, okay, where p tilde of xy is our new p. So let me, instead of writing it down again, sound effects are definitely needed when you're doing math by yourself and trying to write a video for people. Okay, so let's take partial of p tilde with respect to x, not with respect to x. Oh man, with respect to y. Okay, almost made another big one. Okay, so we're going to take the derivative of this with respect to y and compare it with compare it with the derivative of this with respect to x. Okay, so let's take the derivative of this with respect to y is going to be 5 m plus 1 x to the n plus 2 y to the m plus 6 m plus 2 x to the n plus 3 y to the m plus 1 plus 4 m plus 2 x to the n plus 1 y to the m plus 1. So that's the derivative of p tilde with respect to y. I'm just going to check it against what I had last time I taught this course. That's right, I've got a cheat sheet. So far, so good. Okay. We're now take the partial of q tilde with respect to x. What is our q tilde, of course? This thing. Well, not that thing, but you know what I mean. At least you will once I write it down. Or actually, once I copy and paste it correctly. So my q tilde of xy, or my new q, that sounds like a good brand name, mu q. Mu q, I like it. Okay, so my nu q is this monster, 2x to the n plus 3, y to the m, plus 3x to the n plus 4, y to the m plus 1, plus 3x to the n plus 2, y to the m plus 1. Okay, I'm just checking something. Oh, wow. Looks like I hadn't written that m plus 1, so I had it wrong last time, but we're good this time. Just double check again. Yes. Okay, so let's take the derivative of this with respect to x. Okay, so that's going to be 2 n plus 3 x to the n plus 2 y to the m plus 3 n plus 4 x to the n plus 3 y to the m plus 1 plus 3 n plus 2 x to the n plus 1 y to the m plus 1. Okay, so now we want to check that this partial of p tilde with respect to y should be equal to this partial of q tilde with respect to x. So let's go ahead and set those equal to each other. Ooh, running out of space already. I'm being exaggerating here. I'll just do it like that. Don't worry, I'll make it as a good size for you on the PDF. Okay, so let's compare this partial of p with tilde with respect to y. With this partial of q tilde with respect to x. Okay, so now what I want you to notice, is that, look, this power, x to the n plus 2 y to the m, goes with this power, doesn't it? Okay, this power, x to the n plus 3 y to the m plus 1, goes with this power. X to the n plus 1 y to the m plus 1 goes with this power. So what do we have? We have the following equations. 5m plus 1 has to equal 2n plus, 2n plus 3, 6 to the m plus 2 equals 3 to the n plus 4, and 4 to the m plus 2 equals 3 to the n plus 2. Okay, so now that means we have 3 equations and 2 unknowns. So we may actually not have a solution. If we didn't have a solution that satisfied all 3 of these, that would mean that our assumption is bad. Okay, so let's hope and pray to the math gods that this will work out for us. Okay, so let's take the first equation. 5m plus 5 equals 2n plus 6. Let's write that as 5m minus 2n equals 1. Okay, so what did I do? Not too much. I just brought this over here, that over there. Okay, second equation. 6m plus 12 equals 3n plus 12. Okay, ooh, I don't know if I like this one. The 12s are going to cancel. So we're going to get 6m equals 3n. Okay, or let's write it as 2m equals n. A little more space. Let me write it underneath. Okay. Final equation. Let me move it down a little. 4m plus 8 equals 3n plus 6. Okay, so I'm going to do a little my algebra magic. 4m minus 3n equals -2. Okay, so let's go ahead and put n equals 2m into this. Okay, so 5m minus 2n equals 1 is the same as 5m. Now, since 2n is 2 times 2m equals 1, so we get 5m minus 4m equals 1, or m equals 1. Okay, so if m equals 1, that means n has to equal 2. Let's check it against the third equation, because that one we haven't used yet. Does m equal 1 and n equal 2 fit? 4 minus 6 equals -2. Yay! And Alleluia is sung, and you hear it. Okay, so we have a factor that we can multiply. What is our factor? X to the n times y to the m. Okay, just make sure we see that. X to the n times y to the m. So we're going to take our first equation. Let me write it out over here. Let's take this one, this version of it. Okay, since we have n equals 2 and m equals 1 makes this exact, then we're just going to go ahead, write it out. 5x to the 4th y squared plus 6x to the 5th y to the 3rd plus 4x to the 3rd y to the 3rd dx plus 2x to the 5th y plus 3x to the 6th y to the 3rd plus 3x to the 4th y squared dy equals 0. This is an exact equation. Okay, and I won't solve it because this is pretty standard integrals. I think that everyone can handle it. Okay, so the next videos are going to be on inexact equations. So it's going to be very similar in spirit, but there's going to be a more general technique. Okay, I'll see you all in the next video.